Hi, welcome to my video on constructing a line or a segment through a point parallel to a given line or a segment. Using only a ruler and a compass, construct a line through point P parallel to AB. So what you need to do is to draw a transversal to cut the segment AB going through P. So I'll draw a transversal. Transversal is a line that cuts through another line. So here's the line going through P and intersecting AB, let's say at F. Now, what we're going to do to get the parallel lines, or to get a line through P parallel this one, we're going to construct a corresponding angles equal. Because if corresponding angles equal, then the lines are parallel. So I'm going to place the compass at F with whatever radius is convenient. This is a convenient radius here. So draw an arc to cut PF and FB. Place it at P with the same radius and draw an arc to cut PF. So there they are. Now I'm going to say that's cutting PF at G, that's cutting FB at H, and it's cutting here at, we'll say at T. So now we'll take our compass and we'll put it at H, and we'll get the distance from H to G using our protractor. There it is. That's the distance, and we're again as approximations. So that's the same as I put it at G and went to F. Same thing. So I'm getting the distance is the segment from G to H. So I go up to T, which is on the line, PF, go up to T, and I draw an arc. And as it happens, as you can see, that I had this segment on this line, so the one who's going to be parallel to it will be on this line, right here, going through here. So now I have the arcs drawn, so I'll draw a line or a segment from P to those two arcs. So there's P, and we draw. So if I call where these two arcs intersect W, so that means PW is now parallel to AB. And the reason, because this angle right here, this angle, and this one are equal. I copied an angle. So I took this angle, PFB, and I copied it at TP. So the angle PFB is equal to the angle TPW. These corresponding angles are equal. So if two lines are parallel to each other, if the corresponding angle is equal. So since the corresponding angles are equal, this angle is equal to this one, these two lines are parallel. So we're using what we did in the previous video. We copied an angle to get the lines parallel. Now it says construct a circle with a center O and a radius of 4. So let's get a radius of 4. Take a ruler and put a ruler on the end right at 0, 0, right there. There it is at 0, 0. And I stretch it out to have, when I say 4, remember I'm using the unit of centimeters to do the measurement because the centimeters are smaller than inches. So I will move my ruler and I'll draw a circle, put my compass right here, and I'll draw a circle which has a radius of 4. The compass will draw the circle. There's the radius. Here's a circle which has a radius of 4. And I'll mark this. This says construct a circle with center O. So this is center O right here, where that dot is. And the radius is 4 units. Anywhere from here out to the circumference is 4. From here to here is 4. And everywhere, all radius of a circle are equal. Now, the next part of this question, construct the diameter through O parallel to EF, chord EF. So let's draw a chord EF. And I can draw a chord EF anywhere at all. Don't make any difference. I'm just taking it at random. I'm not going along parallel to these lines now. So let's call this the chord EF. So let's call this EH. I got EF, EH. So I want to draw a diameter through the center of the circle parallel to this chord. Remember, a chord is a segment whose endpoints lie on the circle. So that's a chord. Now we need to draw a line through O parallel to. So again, if I want to draw a parallel line, I have to set up O. I'm going to draw a transversal cutting this line or segment. So here we are. Let's do this. Now I could have done going this way. I could have done over here. I could have gone anywhere at all. I just elected to start here and go down and drew this segment that intersected. So what we're going to do is do what we did above. We're going to copy this angle, make corresponding angles equal. So I put my compass, let's say this is A. I'm going to put my compass at A, and whatever radius is convenient. Again, this is pretty good. I'm going to cut the two segments, OA and HA. So there's the arc. So place the compass at O and draw an arc with the same radius. There it is. Now, if I label this as T, this is N, and this is P, then I'm going to get the distance from T to N. So the distance from T to N, open up my compass. There it is, TN, or I could put it at T and go to N, makes no difference. But the only arc I have here, so I put it at T and found this distance. So let's put it at P and find. So putting it at P and drawing arc. So where the two arcs intersect, I have the two arcs intersecting. Now I'm going to draw a segment or a line. Here's the two arcs, and it's going through the center. So I have to join. There we are. Let's go over on the top so you can see it better. So there's the two arcs intersecting. Here's the center. So I'm going to draw a segment or a line. Here we go. There it is. So that means if I call where these two arcs intersect, let's say G, then OG will be parallel to the chord EH. Again, why? Because we made a pair of corresponding angles equal. If you have a transversal cutting through a pair of lines, and these two angles, which are corresponding, are equal, then the lines are parallel. So that line is parallel to that line because of the corresponding angles. So again, we're copying an angle and making the corresponding angles equal. Okay, I have another little question to go over with. A tangent to a curve is a line or segment intersecting the curve at only one point. A tangent is a line or a segment intersecting the curve at only one point. So if we take this point A here and we draw a tangent, this tangent L, let's call it L, is intersecting the circle at one point. So this is the tangent. If you have a parabola, this curve, and you draw a segment and you intersect at one point E. So this is a tangent. So a tangent cuts it at one point. If I do this and cut it at 2 points, then it's not a tangent. A tangent is a line or a segment that intersects a curve at only 1 point. So let's continue with our question here. Construct a circle with 2 tangents parallel to each other. 2 tangents are parallel to each other. So let's first of all draw a circle. Construct a circle with 2 tangents parallel to each other. So let's draw a circle. There we are. Now, just make sure of, okay, and this is the center, and we could, I'm going to just call the center O, because, now, we're going to draw a tangent. So let's take this point right here. If this is a point, 1 point on the curve, this is a point that's on this circle, I'm going to draw a segment that intersects the curve at 1 point. So it's just touching, just intersecting. There it is. So it's going through this point right here. Now let's call this point A. So now we take, if that's A, and we call this B, so AB is a line because I have the raised mark on the end. So this is the line that's intersecting this circle at 1 point. So AB is a tangent because it intersects the circle at 1 point, and that point is A. So what we're going to do now, if I'm going to have 2 tangents parallel to each other, that means the other tangent, if it's going to be parallel, so let's use my pen as this line. Let's say this is the line. My pen here is acting as that line. To be parallel to it and to be tangent, it must mean that I must be over here on this side, right there. So now this is going to be tangent at this point, right here, and be parallel to this. So how do I construct that? Well, let's see. Let's draw a perpendicular. Again, to get the parallel lines, I need angles equal. So let's take the compass, put the compass at O, and I'm going to draw a perpendicular. I'm going to draw a perpendicular from O to this tangent, AB. So here we go. So to draw a tangent, this point is not on the line, so we make an arc, cutting. We make an arc cutting AB at these 2 points. Then we take our compass, and we can just get a certain distance. Remember, the distance got to be more than half of the length of this segment. So if I say this is F and this is H, so the radius of the compass got to be more than half of FH. So there's F, and let's open it. There we go. More than half. Half, probably, let's say half is A, so let's open it up more. Here we have it. So we make an arc. And we did this before in a previous video, so we make an arc. Now we'll put it at H and make another arc, cutting the previous one. There it is. So what I've done now is that from O to that arc is perpendicular to the line. So I drew a perpendicular from O to this line. And so here it is, perpendicular. So if I take this radius right here, or this segment, and extend it. So this is the center of the circle. This is the radius. So if I go right on this line and make another radius and keep going. So if I keep, so this is the radius from O to A. This is the radius from O to, let's see, X. So now I have a diameter, AX. So I want to make, if I got a right angle here, I want to put a right angle here, because if this angle that I'm going to draw right here is equal to this one, the corresponding angles are equal, then the lines are parallel. Okay, so let's extend the line out a little bit more, so when I draw the arcs, they'll intersect. There we go. So let's go down and at A and pick a certain distance. So there's A right there. So I'm going to pick this distance, making sure I'm okay here. Here's A. So pick a distance, and I'm going to cut OA and AF. So I cut OA. This is the angle, OAF. So I'm copying this angle. So I'm going to place my compass at X and draw an arc with the same radius. So there it is. So we go back and we get the distance. Let me mark this where I cut. This is where F is. So let's call this Y, and let's call this W, and let's see where this one is Z. Okay, so let's go back to this angle and copy it. So we place our compass at W and extend our compass out to F, right there. Lift it up, lift the compass up, and go back to where's on this line here at Z and draw an arc. What we're doing, we're copying the angle. So now so it's X to this where the arcs intersect. So remember now, X is one point on this curve. So this is X, this diameter is intersecting the curve at X. So if I join where the arcs intersect and X to form this segment, then this line, let's call it F, F, A, B, C, D, E, G, let's call it H. Oh, H is over here. Let's call it E. Don't want to use double letters, same. So if I make this an E, okay. So that means EX is parallel to FB. Why? Because this angle right here, EXZ, and angle FAW, this is the right angle, this is the right angle. These are corresponding angles equal. Corresponding angles are two angles that are on the same side of, this is the transversal. So these two angles are equal, therefore the lines are parallel. So that's two tangents, a tangent right here and a tangent right here. So FB and EX are parallel tangents. And again, notice that the tangent, if you draw a segment from the center to the point of, that's the point, what we call the point of tangency. That's where the line touches the circle at one point. So this is the point of tangency. Notice that this point of tangency, we have a right angle. And this is the point of tangency. We have a right angle. There's a right angle everywhere, all the way around. Because the lines are perpendicular. This is the right angle. This is the right angle. There's four right angles there. Again, just wanted to do some more construction. The more construction you do, the more help you understand the math we're going to do. Now, click on the end of the video, click on the buttons, the like button if you like my video, click on the subscribe button if you want to be a subscriber to my channel, and visit my website www.mathfullyexplained.com to find more information about me, my videos, and the content. That's the content that I have on my YouTube channel called Math Fully Explained, which is just one word, Math Fully Explained. Thank you for viewing my video. Hope the video helped you. Bye-bye.